as ports. The function of the spool is to move within the sealed case and provide the function of either blocking or opening these ports, depending on the position of the spool. The spool can be moved in many different ways, manually using a button or a lever, or as part of a larger control system using a solenoid actuator. Whatever the method chosen to control the valve, all that we are doing is simply pushing the spool to move within the housing, and by doing this, we are allowing or blocking the path between the ports. In some cases, there may be a solenoid at each end of the valve, whereas in others, there is a spring return. So when the solenoid is no longer pushing the actuator, the spring will return the spool to its normal or rest position. Imagine the example of extending a pneumatic cylinder using a spool valve. The pneumatic air supply is connected to the inlet port 1. Port 2 is connected to the pneumatic cylinder extend connection. Port 3 is unconnected, as it is the exhaust port. In the normal state, without the actuator being operated, nothing will happen, as the spool is physically blocking the airflow at port 1, and the cylinder is retraced because ports 2 and 3 are connected due to the spool position. So any air already within the system would escape to the atmosphere through the exhaust port. Let's consider this the normal or rest position. Now imagine we operate the actuator. We would see the spool position change position and the cylinder extend. This is because the spool has moved position, unblocking port 1 and simultaneously blocking port 3, resulting in allowing airflow from port 1 to port 2 while blocking the exhaust. This is known as our working position. The cylinder will remain extended until the spool is moved back to the normal position, either by way of another actuator at the opposite end of the valve or by an internal spring return. In our example, this type of valve would be known as a 3x2 valve because we have 3 ports and 2 spool positions. Spool valves come in a wide variety of different types and configurations, some having more ports and able to control multiple items of equipment at once. Imagine how a 4x2 or even a 5x3 spool valve might be used. It is also entirely possible to have a standard outer casing with the ports in the same configuration and fit a spool inside of this, which have different profiles. The blocking parts of the spool are known as the lands, which are raised above the spool core. If these are made different in configurations, they can change the way the port pathways interconnect. In this video, we have learned that spool valves are a common way of controlling hydraulic or pneumatic components by allowing, restricting, or blocking the flow of the energy source by way of a simple spool mounted within an outer casing. We have learned that energy sources and components are connected to the spool valve using ports, which are the chambers drilled through the outer casing of the valve. A spool valve can be operated in a number of ways. We could use a button, a lever, or by way of a solenoid. Spool valves are usually referred to by the nomenclature 3x2 or 5x3, etc., where the first number relates to the number of ports and the second to the number of different spool positions. We hope you enjoyed this short introduction to spool valves.